Hello webs, hi, this is Fahad from Future Phones, and today I have a HP laptop to fix, and the model number is HP x360 14-DWQ522. The problem with this laptop is there was a backlight issue, and our board number is latest one of the new ones, and the board number is Laika LAIKA -6050831567001-MB-A01, and the problem with this board is it has no backlight. Another problem we have is we do not have the schematics for this motherboard, so it's quite difficult when you don't have the schematics. So whatever happens at the LVDS connector you don't know, but there are few things that you can test. Just before we test, we can test with a working LCD. So I have another 30-pin LCD. It has backlight, so even this LCD is not giving backlight on this motherboard. Few things that we can test on this board before we go for the repair is there any voltages available at the LVDS connector for the backlight. Usually backlight works with three different voltages. One is the base voltage, which is like it can be from 13 volts to 20 volts, and it can vary between that. This is the highest voltage that is available on the LVDS connector. And then there is a power management signal for the backlight, and another signal which is the enable signal. Enable signal and the power management signal, they go to the backlight boost IC on the LCD section, and in that section 12 volt is the VIN for the backlight, and then the boost IC will need two different signals. One of them will be enable and the other one will be power management. So enable signal will indicate the IC that it is time to work, and power management will work with the user input, which is like how bright you want the LCD. If you lower the backlight, then the power management signal will drop a little bit, and IC will sense that, and accordingly it will boost the IC for the backlight. Now this is our theory, and if we connect this board to our DC power supply with 19 volts and 5 amps, and I'm going into the microscope right now. Straight away is started taking 0.49 milliamps. Since this laptop is working condition, so I'm not really concerned if there is any shortage on the board, and we do not have a schematic, so we will head straight to the LVDS connector. That's one thing. Another thing, to find out the power on button, I have diagnosed it, which is this pin here in the microscope. If you can see, this pin is the power on key. So if I go in the diode range and put my red probe on the ground and black on this pin, this laptop should power on. You see, it's powered on, and our milliamps are I can show you here, is it started gone to 700, up to 700. Now this is the position when the laptop is on, and the voltage should be available at the LVDS connector. Our LVDS connector is here. It's a 40-pin connector. With this connector there is multiple inputs on this LVDS connector, because the touch panel and your camera module or the sensors are also connected to this LVDS connector. But in this one we can see EDP, touch and sensor. So these three are also available, and they also need voltages. So if we don't have a schematic, then our problem is we do not know which signal is for the power management and enable, and also the 13 volt. But we can have a slight guess. If we go in the voltage range right now and start measuring some of the voltages on this LVDS connector. So if we start from here, pin number 1, you can see we are getting 3 volts. It's a good volt. So it could be for anything. I mean, we do not have a schematic, so we don't know. And you can see here it's ground probably. So no voltages here. These voltages are for the display and some are for the touch sensors. So these are some data lines. They are always in 0.600 volt is half of the volt, and the data travels in these in this pull-up supplies. So there is really nothing to check on this one. So we are looking for our 13 volt and power management and enable. So our 13 volt is coming here. So this is the main power supply for the backlight, I know that, and but we do not know which one is the power management or the enable. Well, we are still getting 3.3 volt on the pin number 1, which is a good sign. So we get another 3.3 volt, another 3.3 volt, another 3.3 volt, another 3.3 volt, another 3.3, another 3.3, another 3.3, another 3.3. So this probably is ground. So we are getting quite a lot of 3.3 voltages, but we do not know which one is the power management or enable. In this condition, our possible fault could be the flex cable or the LCD or the power management and enable. If maybe one of the signal that is supposed to come on this LVDS connector is not coming. So but as I told you that we do not have schematics, so we cannot actually make sure that it is coming or not. These 3.3 volts available, they could possibly for the touch sensor or the camera module. There could be anything, you know, on this one. So we do not know really, but we can try one thing, and I want you to watch that. So if I connect my cable to this LVDS connector here, and we can check what is coming on our LCD connector here. So if I just zoom it in a little bit more, put it in some condition where it does not get shorted. Our board is there now, and this is our LVDS connector. I will power on the laptop again one more time. So diode mode range again. Some time to power on. Okay, I will need to check that. I need that pin. So we are on, yeah, between K and E. So I'll just power on again. Oh, we are not in the diode range, so we are in the diode range now. That's why it wasn't powering on. As you can see, it's powered on. The fan is spinning, and you can see there is no display. So if I come here, so we do not get any display. Let's clean this LCD a little bit, because when it's clean, then you can see the display. Yeah, so I can see some display here. You can see there is some sort of keyboard is showing here, but we do not have a backlight. Okay, now we will investigate if our 13 volt is coming here. Let's go in the microscope again. So this is our LVDS connector. So it's pin number 27 actually. (30, 28, 27), and you see our 13 volt is coming here, but our power management and enable, that we need to find out if that is coming. Another thing we can test is let's go to so on this LCD I did not actually know which pin has what voltage. So I have found one image, and that is very helpful. I'll show you in my desktop actually. Here, if we go in the desktop, then we can see that. So this is the image, and wish I could just show it, make it a little bit bigger. Yeah, I can make it bigger. So this is our LVDS connector on the LCD. You can see we have some voltages coming here. The ones we are interested in this, the pin number 27, that will bring 12 volt or 13 volt or any of these LCDs, and then pin number 23 and 22 are the lamp enable and lamp power management. So if we go in the microscope, and remember 22, 23 and 27. So this is our connector on the LCD. Now we are in the voltage range. So pin number 27 should receive 13 volts. So 30, 29, 28, 27, and you can see we have 13 volt coming here. I'll just make it more clear for you guys. Pin number 27 is 13 volt, and also along with it another line 26 is coming. 26, 25, 24, 23, 30, 29, 28, 27, 26, 25, 24 and 23. So we are getting to 20, or pin number 23 we are getting 3.3 volt, and this is the power management possibly. And then enable is you can see we do not have voltages on enable pin, so it's only 0.65 on enable pin. So it is in this condition, because we do not have a schematic, so we cannot actually find out which pin is delivering power from LVDS connector to this side of the LCD. But we can do one thing. If we can give the voltage of power management to the enable pin, because 3.3 is coming on power management already. So if we give that 3.3 voltage to the enable pin, and enable should get 3.3 volt, and in theory we should have a complete voltage for the backlight. So let's check that, and I will use a micro jumper here. So I'll connect these pins together, and then we will check. Okay, so I want to connect these two pins together. And just need a micro jumper, so let's tin this wire first. So this wire is tin now, and I will just connect pin number 23 and 22 together. So micro jumper is complete, and before I'll give power, I will check one more time to make sure I've done the right connection. So let me go back into that image. So pin number 22 and 23 should be connected together. I will count one more time. So this is 30, 29, 28, 27, 26, 25, 24, 23 and 22. So this connection is good. So now what we have done, we have given the power management's 3.3 volt to the enable pin also, and let's check, and do we get a backlight. So power on the laptop again, diode board range for pressing the power button. So it's on now, and do we get a backlight? So the laptop will do few resets before it powers on, and I will take you to this I'll take you to this screen here, and we will see if we get the backlight. You can see we have a backlight. So we have a backlight here. So this is how you can fix this problem. This is fixed for now. So our job is done. I hope you've learned something from this video. We will close it and give it a check. That's it for now. Thank you for watching. Do like and subscribe to the channel, and if you have any questions, you can leave them in comment section. Thank you very much, and we'll see you again in the next video. Thank you. Bye.